Each laser must use a specific delivery device to deliver the laser's energy to the target tissue. A common delivery device is a laser fiber optic. Laser fiber is the material that conducts the energy needed to perform a laser procedure and is comprised of a glass core that is protected by an external plastic cladding. The core diameter of the laser fiber dictates the amount of energy the unit can deliver to a target area. Once a fiber size is selected, the laser-specific connector, located at the proximal end of the fiber, is connected to the laser's beam aperture. When the fiber is connected to the laser and the laser is activated, the laser's treatment beam travels through the glass core of the fiber and out the tip of the fiber to the desired target. Although a powerful tool, the fiber optic cable is also very delicate and can crack or break if used or handled improperly. With that in mind, it is important that the proper precautions be taken to ensure that the laser fiber is used, handled, and maintained in a manner consistent with the manufacturer's recommendations. It is critical to have a thorough understanding of the fiber manufacturer's Instructions for Use manual. This manual contains important information regarding the proper use and handling of the fiber. If using a reusable fiber, it will provide directions on how to properly clean, inspect, strip, cleave, and re-sterilize the fiber. It may also provide information pertaining to the fiber's maximum input power, total energy limit, or maximum number of uses. It is essential that you be aware of the fiber's limitations to ensure the fiber is used in accordance with the manufacturer's recommendations. When preparing for a holmium laser case, it is important to have the appropriate sizes of laser fiber available for the given application. For renal calculi, a 200 or 273 micron fiber is recommended when a flexible ureteroscope is required to gain access to the stone. For ureteral calculi or ureteral stricture, a 200 or 365 micron laser fiber is most commonly used. For a bladder stone or bladder tumor, a 550 or 1000 micron laser fiber is preferred. When using a reusable fiber, provide a copy of the manufacturer's sterilization instructions to the facility's sterile processing department. This will ensure the laser fiber is sterilized in accordance with the manufacturer's recommendations. Common methods for sterilization include steam or ETO gas. Prior to performing any sterilization procedures, ensure that the laser fiber is loosely coiled. Coiling too tightly will likely cause the glass fiber core to crack. The technician should also ensure the fiber connector is covered with its protective cap. When the surgeon is ready to use the laser, it is important to observe the handling of the fiber optic to ensure it remains in good working condition throughout the duration of the procedure. Advise the surgeon and nursing staff of the fiber's delicate nature and provide them with tips on how to handle it properly. If it is necessary to secure the fiber, a wet towel or sponge may be wrapped around the fiber. Never allow the fiber to be secured with a clamped drape wrapped around the fiber, as this may cause the fiber to bend too sharply and cause it to break. Also, never run a fiber cable through clamp handles. Whether on the back table or on the patient, it is important to place the fiber in an area that is clear of any other instruments, such as trays, scopes, or light cords that could damage the fiber. When the laser is activated, always ensure there is plenty of slack in the fiber to avoid creating a pinch, which would cause the fiber to break. During a procedure, observe how the laser fiber is being used. The fiber should not be used in a manner that could put undue stress or strain on the tip of the fiber. While the scope is being inserted into the patient, the fiber should not be advanced beyond the tip of the scope. The tip of the fiber should not be advanced through tissue, nor should it be used as a tool to manipulate stones or other objects, as this could cause the tip to break. Holmium fibers are meant to be used in near contact mode, 0.25 millimeters or less. Advise surgeons to avoid burying the tip of the fiber into the stone or target tissue. When using a flexible ureteroscope, the fiber should be inserted into the scope prior to flexing the tip of the scope. If the tip is flexed prior to inserting the fiber, the tip of the fiber could break as the user attempts to advance the fiber past the bend in the scope, which could damage the scope and potentially injure the patient. It is also important that the surgeon attempt to minimize the flex of the scope while the laser is activated. Immediately following a procedure, collect all laser fibers used during the case. Disposable fibers should be discarded into a Sharps biohazard waste container. Reusable laser fibers should be cleaned and prepared for re-sterilization. Reusable fibers may be cleaned with a germicidal wipe to decontaminate the fiber and remove any residual debris. Once the entire length of the fiber has been wiped down and all residual debris is removed, attach the connector cap and soak the fiber optic for 5 minutes in 4 liters of lukewarm water mixed with 60 milliliters of Enzol or cytozyme enzymatic detergent. The fiber may then be rinsed with warm tap water to remove any remaining residue and debris. Any residual cleaning solution should be rinsed from the connector using deionized water. Using a lint-free towel or gauze, dry the entire length of the fiber. Pay special attention to ensure the connector is dry. Use an air hose to blow off and dry any residual fluid. After cleaning a reusable laser fiber, the proximal connector, the distal tip, and the entire length of the fiber should be inspected for any damage or deformities that may compromise the integrity of the laser fiber. Using a microscope with a minimum magnification of 15 times, inspect the proximal fiber face for damage. If visible damage such as burns, scratches, or chips is observed, the fiber optic is no longer functional and should be disposed of as biohazardous waste. If the proximal fiber face is free from damage, inspect the distal end of the fiber for damage such as melting, fracturing, or other types of deformation. If any damage is observed, the fiber must be stripped and cleaved. To cleave the laser fiber, visually inspect the fiber and cleave approximately 1 inch or 2.5 centimeters beyond the last spot of visible damage. Fibers may either be stripped or cleaved first, depending on the technician's preference. In this example, we will first strip and then cleave the fiber. When stripping, the stripper's size must coincide with the fiber's core diameter. For example, a 200 micron fiber must be stripped using a 200 micron stripper. Similarly, set universal strippers to the appropriate size. Adjust the stop on the stripper to the desired strip length and insert the fiber tip until it makes contact with the stop. Squeeze the stripper handle shut and rotate the stripper to sever the cladding. Then, pull the stripper away from the fiber. If the cladding is frayed, re-strip the fiber. If the cladding is still frayed, the blades on the stripper may need to be replaced. Once stripped, hold the fiber securely along your finger or flat on a hard surface. Use the cleaving tool to score the fiber perpendicular to the fiber axis. Then, grasp both sides of the scored line with your thumbs and forefingers and pull in opposing directions. The fiber will make a popping sound as it separates at the scored line. Ensure that all fiber damage, such as melted cladding, pits, instrument abrasions, and fractures, is removed when the cleaving process is completed. Dispose of cleaved portions into a Sharps biohazard waste container. To test the quality of the cleaving and stripping, connect the fiber to the laser, turn on the laser aiming beam, and project a beam profile onto a white surface. The projected spot must appear as a homogeneous circular pattern. If a scattered or comet tail profile is observed, the cleaving and stripping process must be repeated. To ensure reusable fibers are used in accordance with the manufacturer's recommended parameters, Every reusable fiber must have a corresponding fiber optic tracking log. The fiber optic tracking log provides information such as the fiber's lot number and model number to help identify the fiber. Fibers with the same lot number and model number should be assigned an ID number to distinguish between the two fibers. The fiber optic tracking log also provides information regarding the fiber's limitations, such as total energy limits or maximum number of uses. After a reusable laser fiber is used in a procedure, record the procedure date, facility name, total joules, and how the fiber was sterilized on the fiber optic tracking log. The fiber optic tracking log can be referenced if an incident were to occur. Once a laser fiber has met its maximum number of uses, it should be disposed of into a Sharps biohazard waste container. The fiber optic model and lot number must be entered onto the patient's treatment log documentation after a fiber is used for a case. Record the fiber's total number of joules that were used with the fiber. Document every fiber that was used during the case. It is important that the proper precautions be taken when storing and transporting the laser fibers. The fibers should be stored in a manner that protects them from damage and prevents contamination. Store fibers away from objects that could cause any stress, pressure, or damage to the fiber. Sterile fibers should be stored at mild temperatures with low humidity to avoid compromising the fiber's sterile packaging. Avoid taking sterile fibers into common areas, such as the lounge or cafeteria, where they may become contaminated. Do not place fibers directly on the floor. This concludes the laser fiber optic use and management video. Thank you for watching.